Tree of Knowledge is a statistics software for social scientists. Like other statistics tools, this online platform allows you to upload, analyze, and model data sets. But it is also unlike any other statistics tool. It introduces a radically new approach to statistics which delivers insights that are orders of magnitude more reliable, detailed, and accurate than has been previously possible. More specifically, this new approach to statistics enables the creation of the first universal, comprehensive theories. Let's look at what these three words mean, starting with universal. With currently existing statistics, you always analyze a single dataset, allowing you to detect patterns in this dataset. Or, more specifically, it allows you to determine the patterns and rules that apply to the specific setting from which the data was collected. But honestly, knowing what happened in this one specific scenario has very limited value and isn't much use to anyone. What we truly need is a set of universal rules, principles that extend beyond a single dataset and apply to all humans in all settings. Only then can we achieve a true understanding of human behavior. But how could we find such universal rules? Well, with conventional statistics that analyzes the data from just a single study, finding truly universal rules is impossible. There is simply no way to determine whether a rule applies universally by testing it in only one specific scenario. No. The only way to establish a rule's universal validity is by checking for its existence across a wide range of different environments. This is exactly what Tree of Knowledge does. It makes use of the fact that there are thousands of data sets openly available that contain information about people in a diverse range of circumstances. By evaluating and refining rules across hundreds of these data sets, Tree of Knowledge identifies patterns that hold true across all contexts, allowing us to uncover genuinely universal rules. Next, let's look at what a comprehensive theory is. Consider the complexity of the human mind. The human mind is incredibly complex. In a psychological study with 100 participants, you might observe 100 different behaviors. That's because human behavior is influenced by a vast range of factors such as goals, expectations, character, and feelings. When you examine it closely, it becomes clear that the human mind is highly complex and interdependent. Unfortunately, traditional statistics offers little hope of truly understanding this complexity. That's because conventional methods can only be used for studying the effects on a single variable, allowing researchers to analyze only a tiny piece of this big system. The problem with studying just one small part of such a strongly entwined system is that there is no way to filter out the other factors at play. The other factors either distort the measurements with massive bias, or, if you attempt to randomize over them, introduce so much noise that any meaningful signal is lost entirely. No, the only way to even begin understanding something as strongly interconnected as the human mind is by having a comprehensive model that can account for all of the interacting effects present in the data. Only such a cohesive, big model can deal with all the different effects and provide real insight into what is truly happening. Tree of Knowledge allows for the creation of such models. The challenge with such a massive model is training and evaluating it. No single dataset contains enough information for training a model of this scale. Fortunately, Tree of Knowledge overcomes this limitation. Unlike traditional approaches that rely on single datasets, it can train and evaluate models on hundreds of different datasets simultaneously, allowing us to get a complete and accurate understanding of the human mind, despite the noise and bias inherent in individual datasets. This is the same training on many datasets as we saw earlier. Lastly, theories. theory is a scientific term that denotes how strongly a scientific finding is proven. A hypothesis is a phenomenon for which there is no evidence yet and therefore zero proof. A scientific finding is a phenomenon that has one point of evidence, such as a statistically significant study result. A theory is a phenomenon for which there are multiple independent pieces of evidence coming from different sources. For example, the theory of evolution is supported by evidence coming from as diverse sources as the shape of finches' beaks, similarities in animal bone structures, the fact that selective breeding works, and many more. Scientific theories are orders of magnitude more proven and reliable than scientific findings. This is because a single source might by chance contain evidence for a phenomenon that doesn't actually exist. However, it's practically impossible for many completely unrelated sources to all point to the exact same phenomenon and it not to be real. We can also see this in practice. The replication crisis showed the majority of statistical findings to be false. The scientific theories, on the other hand, have stood the test of time. All existing scientific theories still hold true to this day, with only some of them requiring a slight modification. With conventional statistics, we are limited to generating scientific findings, as these statistics only consider the evidence from a single dataset or study. Tree of knowledge, however, allows us to establish reliable scientific theories rather than just findings. This is because, as mentioned earlier, Tree of knowledge evaluates models on data coming from a wide range of different sources. For a model to be accepted, evidence for the phenomenon must appear consistently across all these different sources. Moreover, the evaluation process is fully automated, enabling Tree of knowledge to include more sources in the evaluation than even the famous theories had. In summary, this new approach to statistical modelling allows us to move away from simple statistical models that are trained on only a single dataset to statistical theories that are trained and evaluated on hundreds of datasets. As we just saw, evaluating these theories on hundreds of very different datasets instead of just the one makes them vastly more proven and robust. And using data from across the globe allows us to verify the universal validity of these theories. It is also important to note that training the theories on so much more data makes them significantly more accurate than their classical counterparts. Let's take a closer look at the models being trained. With Tree of knowledge, we can train and evaluate the same models as with conventional statistics. Due to the wealth of datasets, we can however go further and train much more complex models. This enables us to get a detailed understanding of highly complex systems, such as the human mind. There are some additional advantages. With the simple statistical models, you can, at best, capture the general trends of a macroscopic variable. The complex and detailed models can, however, do much better. They can be used for creating exact and detailed predictions that take into account all the internal phenomena as well as the specific surroundings. In Tree of knowledge's case, these precise predictions come in the form of a simulation. Not only are these simulations significantly more accurate than their macroscopic counterparts, they are also intuitive to understand and can be inspected in detail, thereby giving you a precise understanding of the mechanisms at work. Now, let's talk about the probably greatest advantage of this statistical theory approach: its incredible power. You have to realize that the simple statistical models can make predictions for only one specific scenario, the scenario that had been captured by the underlying data. In contrast, our complex model here has been trained on data coming from hundreds of different settings and shown to work in all of these different scenarios. This makes it a truly universal and versatile model that can be used to make accurate simulations of any situation. In other words, we can use this universal theory of the human mind to predict people's behaviour in any scenario, making it an exceptionally powerful tool that is useful in a wide range of cases. Finally, let's talk about the platform itself. Statistics is hard, and mistakes are unfortunately more common than people would like to admit. The online platform, Tree of Knowledge, has been designed to be as easily usable as possible. So for one, no programming is required. You can transform data, design models, and train them all with easy-to-use interfaces. And the platform is built upon a rigorous Bayesian statistics framework that frees the user from most difficult statistical decisions, thereby minimizing the amount of statistical expertise that is required and drastically reducing the number of errors that can be made. Lastly, this online platform enables the large-scale collaboration of many researchers. When researchers study different parts of the human mind with traditional statistics, then their findings remain isolated and cannot be combined in any meaningful way. In Tree of Knowledge, the researchers can do the same research, only that now these insights are connected by being part of the same cohesive model. So, when using classical statistics, further research only leads to an ever-growing pile of disconnected insights. These insights do not fit together, and many of them even contradict each other, leaving us with a confusing collection of incohesive and partially contradictory findings. In Tree of Knowledge, on the other hand, researchers can still focus on their area of expertise and work on expanding our knowledge in these specialized areas. Whatever they do will, however, also improve the big comprehensive model. They can, for example, refine our understanding with more data sets, find better models, or expand the big model into new areas, leading to an increasingly accurate and comprehensive understanding of the human mind. We will end up with a powerful and detailed comprehensive theory of the human mind, which has been shown to work accurately in hundreds of different scenarios, and which can be used to accurately model humans in any environment. Now, the human mind was just an example. This new statistical theory building approach can also be used to develop powerful statistical theories of other highly complex and interconnected systems, such as countries, companies, institutions, organs, plants, and animals. The advantages of these statistical theories over traditional statistical models are not just incremental improvements, they are game-changing. This new approach will have a profound impact on many statistics-based sciences, bringing them a level of rigor and predictive power that, until now, has only been possible for sciences dealing with far simpler systems. We believe that the dramatic increase in scientific rigor and cooperation will have far-reaching consequences for these statistics-based fields, enabling them to progress at levels that haven't been seen before, and paving the way for many groundbreaking developments. Ultimately, this will greatly increase the impact and influence of these fields and shape the future in profound ways. For more information, visit www.treeofknowledge.ai.